Hi, this chapter is chapter 22, and then in this chapter, we will be able to study what is called AC circuits. AC circuits means alternating circuits, where we have AC, which is alternating current. We will study here the behavior of resistors, capacitors, as well as inductors. Now, the first thing we want to say it is what does it mean? What does to have an alternating current? The AC means that the current is gonna change in magnitude and direction as a sine or a cosine wave. It doesn't matter. Then this is really I, the current, in amperes versus time. It is keep on changing its magnitude once it will reach with this, I0, which is the maximum value, and then it will decrease till it reaches 0 here, and then it's going to go to negative I0 and go on. Now, also, I will say, what does it mean to have an AC source? The AC source, it is a source or the source that is providing a changing voltage, magnitude, and direction. Now, always we can say that the voltage at any time for this source as a function of time equal V, which is the maximum potential difference, times cosine omega t. And V here, it is the maximum. Either we call it potential difference or we call it voltage. And of course, this is in volts. We call this number or like this quantity the voltage amplitude. Whereas here, lowercase v, it is the instantaneous value of the potential difference. And that is actually also in volts, then this is really the voltage or the potential difference at any moment. Omega, it is the angular frequency. It equals 2 pi times the regular frequency. And F here, it is the number of cycles per unit time, and it is measured in hertz. Now, here in the United States, we have the frequency for the source. It is 60 hertz. And I will say omega, therefore, is going to be 2 pi times the frequency, and that it is 2 pi radians times 60 hertz, and that it is 377 radians per second. And the current as a function of time is going to be I or I0 cosine omega t as well. It can be represented the same way. And I here, we call it the current amplitude. It is in amperes. And I, the same way, it is the instantaneous value of the current at any moment. And also it is in amperes. Now we use in circuits to represent AC, we use this notation. Then just to tell that this is an AC source, this is the way that we are using. Now here I will say these voltages and currents are really sinusoidally varying, and therefore we need vectors to represent them. We call these phasors. And we represent them using what is called phasor diagram. And for example, here I will say, let's assume here I want to represent the current as a phasor. This is O, and this is my I. And this is omega, the angular velocity, and therefore the angle here, it is omega t, and then therefore at any moment this is representing I, which is I cosine omega t. The length of the phasor equals maximum current I, and it rotates with frequency f. Now, one important thing we want to talk about is always for these type of values when they are changing, we define what is called IRMS, which is we call it the root mean square current. This is a statistical value, and we know that this value, the maximum value divided by square root of 2. IRMS is never 0, and I will say, if I can say I squared is going to be I squared cosine squared omega t, then we know also from trigonometry, that cosine squared of a quantity equals 1/2 1 plus cosine 2a. Therefore, I can say I squared equals I squared times 1/2 times 1 plus cosine, here it's omega 2, and from that one we can say I squared equals 1/2 I squared plus 1/2 I squared cosine 2 omega t. Now the average of cosine 2 omega t is 0 because it is positive, going positive and negative, and therefore the average of I squared simply is going to be I squared over 2, and the square root of this quantity, we call that IRMS, which is I divided by square root of 2. This is how we verify that this one is, the IRMS. And just as I said, it's just an average quantity. Now also I can say VRMS, it is V divided by square root of 2. Okay, I will have another video for the next part.